Okay, so on this one, find the critical values, get us a function, separate multiple answers, blah, blah, blah. All right, so what the world's a critical value? That's an x value with f prime of x equaling 0 or positive or negative infinity. And we're not going to get infinity, I don't think. But we're gonna take the derivative. So let's bring this function on down. So here's our function. If I get a little scribbly, grab it right here. And I'm going to rewrite that as a half power, or really, how about a 0.5? Just might be even easier, right? Square root of x, remember, is 0.5 power. So let's take the derivative. So that 0.5, so that'll be half of 2, which is 1, and subtract 1 from the power minus 0.5, minus, and then bring down the 2. Subtract 1 from the power, so it's just x to the 1. There we go. There's the derivative. And what are we going to do with that derivative? How are we going to solve it? Because now we want to set it equal to 0. You tracking with me? Because that's what memory critical value is, a place where the derivative, the first derivative, is 0 or infinity, but there's no way the thing's going to become infinity. So so it's 0. Maybe there is. Yeah, 0, 0 or infinity. I'll say or infinity. Okay. Anyway, so you think, well, how do you solve this kind of a weird thing? Well, basically, what we're always going to do is we're going to factor. So here's how you want to look at it. Let me help you. See how there's two terms right here? That's how you should look at it. Pluses and minuses are separators. And so that tells us how to look at this thing. There's two terms, and what do they both share in common? Both terms, both terms have an x. Oh, so both terms have an x. So factor out, oops, the lowest power. Factor out the lowest x power. So which one of these is a lower, get some room here. Whoa, I'm going a little crazy. Looking at these two, this term and this term, which one has, this is x to the 1, right? It's invisible, positive 1. So this one's lower, it's negative. Okay, so what? So factor out x to the negative 0.5, put a parenthesis, keep the equals 0, that's on the right side there, right? So back to 0. There we go. And then how do you know? Okay, so I got it and all, but how do you know what goes here and here? You're going to have a minus in the middle. Just ask yourself what works. X to the minus 0.5 times what? Times 1. We'll go back to 1, x to the minus 0.5. And x to the minus 0.5 times what? Ah, now that's tricky. Let me show you. It's going to be minus 2x. My pen's getting a little, it's going to be, sorry, get the minus 2x to the 1.5 power. How do I know that? Well, because when this guy hits this guy, the powers add and it goes back to x to the 1. Let me make sense of that for you. Do you remember these rules from earlier math? X squared times x to the third. What do? You add them, right? You add powers because that means two x's and that means three x's. And so we have five x's. So you add powers. So therefore, what would x to the negative 0.5 times x to the positive 1.5 be? Well, you'd have to take 1.5 minus the 0.5. That's going to equal x to the 1.0, or just x, right? Let me just get rid of that last x. Just making sense here? So in other words, when you multiply two x's that have powers, those powers add and subtract together with a single x as the base, right? You see it right here. X squared times x cubed is a single x in the base, powers added, 5. Well, then same thing right here. Right, let me do it more slowly. These guys, let's do it right here. So these guys multiplied together one more time. X to the minus 0.5 times x to the 1.5. What'll happen? Single base, take those powers minus 0.5 plus 1.5, right? Just like 2 plus 3 is 5. And what is that? X to the positive 1. 1.0 if you want, or just 1, right? Because 1.5 take away 0.5 is 1, isn't it? $1.50 take away 50 cents is $1. So it's X to the 1. So my point is this times this power and this power add to go back to x to the positive 1. And of course, the 2 is in the front, so it's right. It's right. You see that? So if I was to multiply this times this, it goes back to this, and x to the minus 0.5 times that, the powers will add, subtract, and it'll go back to x to the 1. It's correct. I'd correctly factored, and you got to spend some time working with that to make sense out of that. Okay, but anyway, and why did I even put this out here in the beginning? It's because you always factor out the lowest power x. So if you have two terms equal to 0 and they both have x, take out the lower power and then just put inside whatever makes it work. This times 1, this times x to the positive 1.5. Take away 0.5 goes back to x to the 1. All right, let's quit beating this horse. Let's finish this up. So now each part is going to equal 0 separately. Why? Because this is multiplied by that and they're equaling 0. How can you multiply two things and get 0? Either the first one is 0 or the second one is 0. Right? That's just logical. Two things are multiplying, these parentheses are multiplying to equal 0. How can two things times each other and come out 0? If the first one's 0 or the second one's 0. Now, um, not sure where to go from here. Um, what we could do, yeah, right. Okay. Yeah, let's finish it up from here. Um, when you have a negative power factored out, right? What does that negative power mean? Remember that means 1 over x to the positive 0.5. Remember that? Remember a negative power is unhappy where it's at. It wants to jump to the bottom and then the power becomes positive. Lot of little intense algebra rules here you got to learn. Negative powers are unhappy where they're at. They want to jump to the bottom. Okay, great. So what? So do you realize? So I should have said 0 or infinity. Remember, from the beginning, that's what a critical value is. Any place the derivative is 0 or infinity, right? And notice that when we took the derivative, if x happens to be 0, then this is 1 over 0 to the 0.5. So what? Well, that's 1 over 0. And what is that? Infinity or undefined, however you want to say it, same thing. My point is x equals 0 is a critical value. It's our first critical value. We're going to get another one. It's a critical value. What do you mean? What's a critical value? Don't forget up here. A critical value. A critical value is an x value where the derivative is 0 or infinity. And I'm telling you, when I see this little equation, I know that really means an x in the denominator. That means if x is 0, I'm just looking at it. I'm just solving by observation, they call it. I'm just looking at that x. When you have x in the bottom of a fraction, that means if that x is 0, then the bottom of the fraction is 0, and that's equal to infinity, do you know? Which is undefined, right? Why? Why is that? The bottom goes into the top forever. Remember, a fraction means bottom into top, bottom into top. Like if I have 10 over 2, we all know the answer is 5. Why? Because the bottom goes into the top. 2 goes into 10 finally. So how many times does 0 go into 1? It goes in there forever. Goes in and in and in and in and in, never filling up once, infinity. So that means when you let x be 0, x equals 0 is a critical value because it makes the derivative infinity, doesn't it? And if you make the derivative, if you make the derivative 0 or positive infinity or negative infinity, either one, you're a critical value. So I've got one critical value. As soon as you got x to a negative power, that's in the denominator, and anything making that denominator 0 makes the whole thing infinity. So x equals 0 is a critical value. The other one is to take this little equation over here and solve for x. How do we do it? Well, subtract 1 on both sides for starters. Boom, it's gone, and we got minus 2x to the 1.5 is negative 1. And we need some more room here. It's got some tricky steps to it. And then divide by negative 2. So, boom. So x to the 1.5 is 1/2, right? The two negatives cancel. Okay, so what? So how do we finish solving for that? You ever thought about that? How do you do that? Well, let me show you. So if you have x to the 1.5, and this is 1/2, couple things you can do. I'm just going to suggest this. You want to, what's our goal here? We want regular x, right? We just want regular, normal, everyday x. That's we're trying to solve for x, just plain x. I don't want this weirdo 1.5 power on there. Well, how do you get rid of that weirdo 1.5 power? What you do is you raise it to the 1 over 1.5. Whatever you do to one side, you have no choice but do the same thing to the other. And then these will cancel. And this will be x to the 1 or just regular x. Is that making sense? So whenever you have some funky power on x and you want to just make it x to the 1 because that's just normal x, just raise it to the 1 over that funky power, both sides, right? Because whenever you do to one side, you have no choice. You got to do the same thing to the other to keep them equal. And these will cancel. Why will they cancel? Well, because 1.5 is over 1 and 1 over 1.5, they cross cancel. It just becomes x to the 1. Now, what's this side? Let's go hit the buttons on our calculator. It's 1/2 to the 1 over 1.5. So it's 1/2. Let me go there. So it's 1/2. So I'll go parentheses. Oops. 1/2 to the power 1 over 1.5. There it is. 1/2 to the power 1 over 1.5. I'm getting 0.629960, 0.629960. Is that the answer? There it is. That's one of the answers, right? 0.6299. There's that one. And the other one is the 0, which we got. We got both. They're both answered, right? X equals 0 was a critical value. We kind of lost it maybe. And x equals this one, 0.69. I can't remember now. Whatever it is, I'm just going to leave it. So there's two critical values. That's a pretty hard question. Let's recap. This was worth a recap. What do we do? Whenever they ask for a critical value, we go, okay, that's either where the derivative is 0 or infinity. So I took the function, I took its derivative, and that wasn't too bad. And then I realized, oh, okay, you've got to factor out when you have two terms that both have an x, take the lower power, negative 0.5, factor it out, put inside whatever will work, so those powers will add to go back, and then set, and if two things are times, you need to equal 0. But the first part to 0, second part to 0, or infinity. And we see that x to a negative power is 1 over x. So that means if x is 0, that's 0 in the bottom of a fraction, 1 over 0, that's infinity, that's undefined, so that's going to be a critical value. X equals 0 was our first critical value. Then solving the other side equal to 0, that was tricky as well. We had to get x alone, and that meant putting 1 over 1.5 power. And we got that weird, funky answer from our calculator. Let me write down, what is it? 0.62996. 0.62996, 0.62996, and of course, x equals 0. These are both critical values. They're both numbers, x values, that'll make the derivative, the slope, 0, flat, or infinity. They're both critical values, right? And so there we go.